Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about engineering notation. Engineering notation is very similar to scientific notation, and I did a video on scientific notation previous to this, but there's two differences. It's still a number times the power of 10, but now the number is between 1 and 1,000. And the exponent is an integer, but it has to be a multiple of 3. So if we had a number like 315,000, if I were to write that in scientific notation, it would be 3.15 times 10 to the 1, 2, 3, 4, 5. A number in scientific notation has to be between 1 and 10, and then the exponent has to be an integer. But this is not engineering notation because this exponent is not a multiple of 3. Multiples of 3 would be 3, 6, 9, 12, 15, and so on. Similarly, -3, -6, -9, -15. Numbers that 3 divides into evenly. So if we were to express this in engineering notation, we're going to move our decimal point 3 places at a time until we get a number between 1 and 1,000. So my decimal point is at the end of the number, and I move it 3 places. This is a number between 1 and 1,000, so I'm going to move my decimal point 3 places. And when I do that, I will end up with 315 times 10 to the power of 3. This number is between 1 and 1,000. My exponent is a multiple of 3. Therefore, this is engineering notation. So all 3 numbers are equivalent. This is in normal notation. This is scientific notation. This is engineering notation. Let's take a number 0.0000002 and change that to engineering notation. So again, we're going to move our decimal point in groups of 3 digits until we get a number between 1 and 1,000. Now, it's not between 1 and 1,000, but if I go 3 more digits, so I need a 0 here. If I go 3 more digits, I now have 20, which is between 1 and 1,000. So I can write this as 20 times 10 to the 3, 6, 9, and because I'm going to the right, it will be -9. -9 is a multiple of 3. Engineering notation is very useful for expressing large or small numbers and also to use with the metric prefixes. So let's take a look. Let's say we have this number. Sometimes it's hard for people to understand the size of that number when they see a lot of zeros. So if we were to write it in engineering notation, this would be equivalent to, we move our decimal point 3 digits at a time until we get a number between 1 and 1,000. 710 is between 1 and 1,000. And we moved it 6 places, so that's 10 to the 6th. So this is 710 times 10 to the 6th, and we know 10 to the 6th is equivalent to 1,000,000. So we could write this as 710 million. And that's often easier for people to understand when they see it with a lot of zeros, especially when we get into billion and trillion and so on. Engineering notation also makes it very easy to work with our metric prefixes. If we take a look at a table of our scientific metric prefixes, we're going to notice that the powers of 10 are multiples of 3. So we have 10 to the 18 for exa, 10 to the 15, 10 to the 12 for tera, 10 to the 9th, 10 to the 16th for mega, 10 to the 3 for kilo. Then values less than 1, 10 to the -3 is milli, 10 to the -6 is micro, 10 to the -9th is nano, and so on. So all of these exponents are multiples of 3. These are the symbols for those prefixes. If we have really large or really small measurements, it often makes more sense to express them with the appropriate metric prefix. So for example, if we had 0.00025 amperes, what we can do is write this in engineering notation. So we're going to move the decimal point 3 places at a time until we get a number between 1 and 1,000. I'm going to put a 0 there so I can move 3 places at a time. We're going to get 250 times 10 to the, I moved it 6 places to the right, so that'll be a -6. And we can take a look at our table. 10 to the -6 is equivalent to a micro, and the symbol for a micro is a Greek letter mu. So instead of writing the 10 to the -6, we can replace that with micro and then put my base unit of amps. So this value would be equal to 250 microamps. Let's take a look at some more examples. If we had a resistance of this size in ohms, we can rewrite this in engineering notation. So this will be 36 times 10 to the, we move it 6 places. So that's 36 times 10 to the power of 6. We take a look at our metric prefixes. 10 to the power of 6 is mega. So we can replace 10 to 6 with mega. So our measurement would be 36 mega ohms. Notice that the symbol for these prefixes are all capital letters, and then these ones are small letters. Let's do a couple more examples. We have a power of 300,000 watts. Again, let's write this in engineering notation. We're going to move our decimal point 3 places at a time. 300 is between 1 and 1,000, so this will be 300 times 10 to the power of 3. 10 to the power of 3 is kilo, so we can replace 10 to the power of 3 with kilo, so we'll have 300 kilowatts. In our last example, we have 0.008 seconds. Let's write this in engineering notation first. So I move my decimal point 3 places at a time. I will have 8 times 10 to the, I'm moving to the right, so it will be a -3. 10 to the -3 is equivalent to milli, so I can replace 10 to the -3 with milli. So my measurement would be 8 milliseconds. You may have an engineering function notation on your calculator. So if you change your calculator to engineering mode, your values are always going to be expressed in engineering notation. And in some calculators, they may even put the metric prefix in instead of the power of 10. So check out your calculator and see if yours can work in engineering notation.